This is geotrig, day 2 of the trig identities. So we're now on to our third identity. This one, guys, is verified. Now these ones have an end game. This follows the directions that we had yesterday in that video, where you only are going to work one side of the equation. I understand this looks like an equation because it does. It says equals. Normally, when I solve an equation, I can bring things from one side to the other, multiply both sides by 2, divide by 8, square both sides, la-di-da-di-da. Guys, on verifying identities, no. You will act like that equal sign is a brick wall. You are not allowed to cross it. So, the goal here, again, is to verify one side is the same thing as the other by not actually changing its value. If you remember back to those steps from yesterday, it always said, take the more complicated side and then simplify that one. What looks more complicated? Things on the left or the things on the right of number 3? I think the left. There's a lot more stuff to work with. Okay? Sine squared does equal something. It actually equals the square root of 1 minus cosine squared. That's something you might want to think about. You remember that whole chess game, that checkers game that we said we're going to play today. We're playing. You got to think 3 to 4 moves ahead. You should know that the right-hand side of sine squared is one of our Pythagorean identities, which means sine squared plus cosine squared equals 1. There's a sine squared. I could solve it for sine squared by subtracting cosine squared to the other side, which leaves me with 1 minus cosine squared. Sorry, there's no square root on that one, because it's sine squared. So somehow, if I'm able to get the left-hand side to say that, I know I'm one step away from solving or proving or showing, verifying that the problem is true. The answer is already in front of us. The left-hand side is the right-hand side. You just need to connect the dots. This is not one of those things, guys, where you can look at someone's paper and say, look, they wrote down sine squared. I'm good. I'm going to put the answer down. No, the answer is already given. Now you need to connect the dots. Make sure that you can get from one side to the other in a nice flowing manner. Now this is where sometimes people are going to go in a circle and end up back to where they began. Or somebody's going to take 15 steps to get there. And then they're going to look at their friend's paper next door and go, you just did the same thing in 2 steps. What the heck? It's going to happen. There are going to be times we are going to, as a class, do problems like this, and we're going to take a really long time, and then somebody is going to raise their hand, and they're going to go, Mr. Konchak, I did it this way, and I got it done faster. And then we'll show that way, and show that that is also an option. There's more than one option to do this. This is what makes this so great. This is what math is all about. It's not necessarily an answer, it's how you get to that answer. There's more efficient methods, and there are longer methods. Now, I agree. Let's work with the left-hand side. So what can I do with the left-hand side that potentially could change it but not really change it? Wait, what do you mean? That means 4 quarters equals $1. So therefore, I can interchange them, which changes it but doesn't change its value. What can I do?
Could you have Pythagorean identities?
I'm not going to work with the right-hand side. I'm going to work with the left. So I don't want to use the Pythagorean identity. One of those rules, guys, was switch everything to sines and cosines. Right now I see a cosine, a secant, and a cosine. So secant can be changed to what? 1 over cosine.
What? What's happened?
Not cofunction. I'm using the reciprocal trig functions or identities. So secant is 1 over cosine. You guys remember this? This is not the first time we saw secant, so we should know that. Hey, what can I do with cosine now? multiplied in. Distribute. What is cosine times 1 over cosine? 1 minus cosine cosine. Cosine squared theta. What does 1 minus cosine squared equal? This is, I already explained this. This is that one step away thing that we were thinking ahead.
Oh, that's the. If you add the cosine, then does the sine equal 1?
Using this identity right here. What happens if I subtract cosine to both sides? So sine squared theta is equal to 1 minus cosine squared theta. So wait, if that's the case, this thing right here is this thing. So doesn't that just equal sine squared theta? And isn't that the same as what I'm asking you to look for? Check, we just did it. I just made the left-hand side look like the right-hand side. Eventually, you should have both sides be saying equal the same thing. Okay, we got to verify this one now. 2 tangent of x secant of x is equal to 1 over 1 minus sine x minus 1 over 1 plus sine x. What side looks more complicated now? The right side, the ones with the fractions. So what can we do with fractions when they're subtracted? Put them together. How do you put them together? Common denominators. That common denominator would have to be made up of a 1 minus sine x and 1 plus sine x. So, guys, what I'm going to effectively do now is I'm going to ignore the left-hand side, is I'm not going to write it anymore. But knowing that my final answer needs to look like it. So, if I'm looking at these fractions, I think everybody should understand that I need to multiply the tops and the bottoms by something to make those work. What should I multiply the top and bottom of the first fraction by to make it have a common denominator? The first one, yeah. 1 plus sine x. 1 plus sine x. You multiply by the top and bottom because really you're multiplying by 1. It doesn't change it, yeah? The second one, I multiply by 1 minus sine x. Okay? Well, here's a cool thing about this. 1 plus sine of x times 1 is 1 plus sine x, right? I'm going to keep it in parentheses. The reason is because eventually it's all over something, but this group is subtracted because it's a negative 1 times 1 minus sine x. Do you guys see that? Because that 1, that negative, has to be distributed in. That's going to be huge. And then you have to put the bottom together. Now, guys, sometimes there's advantages to multiplying your denominators together. Other times you want to keep them separated. But here's the thing. 1 plus sine x times 1 minus sine x. Does anybody know what results from something like that? A plus b times a minus b. The difference of squares. So that might be something we actually want to put together this time. And so, what's 1 times 1? It's 1. 1 times negative sine x? Negative sine x. Sine of x times 1? plus sine of x. And sine of x times a negative sine of x? Negative sine squared x. I can cancel all the middle terms. I think everybody should see that. Now, as I'm moving on to my next line, I think everybody should now see that, hey, I'm going to put the top together. And if I do that, I end up with 1 plus sine of x minus 1 plus sine x all over 1 minus sine squared x. Is everybody okay with that? Just gathering like terms. Hey, wait a minute. What happens with the ones on top? They cancel. Hey, what happens to the signs on top? They don't cancel. They add together. Sine of x plus sine of x is? Hey, I like that. All over 1 minus sine squared x. What if I could change that? What can I change that to? Not tan. Cosine squared x. Why? Because the packet says so. Because sine squared plus cosine squared equals 1. I'm going to change colors. I'm going to write this on top so you guys can see it again. If I want this result from the thing that's here in purple, it means I got to subtract sine squared from both sides, right? And if I subtract sine from both sides, sine's gone. I'll have sine on the right-hand side, leaving me with cosine squared. Oh, so that's just cosine squared. Well, that's pretty cool. Hey, look, guys. I want this, right? I want 2 tangent of x secant of x. Cool? There's a 2. I got a 2, guys. Hey, wait. Let's think of this. Let's think. Think ahead here. I need tangent. But what is tangent? It's sine over cosine. Do I have a sine over cosine? Yeah. I do. Wait, but it's a cosine squared. Wait, guys. This is a fraction, and this is multiplied stuff together, like 2 times sine of x times 1 over cosine squared. Could I split this up? Would you guys be okay with me saying, hey, that's 2 sine of x over cosine x times 1 over cosine? Really, if I want, I could put this as 2 over 1. How do you multiply fractions, guys? You just cross the top, cross the bottom. So isn't 2 times sine of x times 1 2 sine of x?
Yeah.
Isn't 1 times cosine x times cosine x cosine squared x?
Yeah.
2 divided by 1 is?
2.
Sine over cosine is? 1 over cosine is? Check. That's x.
Where did you get the tan?
Next one. Cosine u over 1 minus sine u is equal to secant u plus tangent u. I'm asking you guys to make this one work. Try this one on your own. Like we talked about off video, I'm going to start with the right-hand side because I feel that I could change those into fractions and potentially put them together to get something. So, when I do that, I end up with 1 over cosine u plus sine u over cosine u. Hey, wait a minute. That's already got a common denominator. Isn't that 1 plus sine u over... Oh, wait, guys. I just added them together. Common denominators. But how do I switch those? Yeah. I can't change 1 plus sine u to like secant or cosine squared because they're not squared. So that means that Pythagorean identities probably aren't going to work here. How? Wait. But so I got stuck. I'm basically at this point the same position as I am on the left-hand side. It's not undefined. What's it? You can't cross multiply because we can't cross the equal sign. Multiply by the reciprocal, that would equal 1. That would change it. I have to multiply here, guys. I have to multiply by 1. So that means I kind of have to introduce something. And a lot of times, that necessarily you wouldn't do that with this problem here. Let me explain. Would you guys be okay with this? 1 over square root of 2? Are we okay with that?
No.
What do you multiply by? Square root of 2 over square root of 2. Okay, let me change it. Are we okay with this? No, what would we multiply this one by to get rid of that square root of 2? Not square root of 2 plus 2, but square root of 2 minus 2 to the top and bottom. Right? You guys remember doing that? Rationalizing denominators? What if I said that same technique, guys, of this, same technique that you're doing here could potentially affect this. Or if I started with the left-hand side, this. What does, listen, if I could change something, I could multiply this one, the top and bottom, by, not 1 plus, but 1 minus. It's not going to cancel out the bottom yet. Not yet. Is everybody okay with me multiplying by 1?
Yes.
That's a legal move. What do you have to do on the top? 4-letter F word.
Foil.
Foil. So 1 times 1. 1 times negative sign. Sine u times 1. And sine times negative sign. Negative sign. Squared u. All of this gets over cosine u 1 minus sine u. Are you guys okay with that?
You can simplify that.
I could simplify that. Yeah, I can get rid of these, right? Which then leaves me with 1 minus sine squared u all over cosine u 1 minus sine u. Hey, wait a minute. Don't I want a 1 minus sine u on the bottom?
Yeah.
I don't want that cosine on the bottom. I want a cosine on top. How am I going to get that cosine on top? I can't multiply by reciprocals. Wait, why? Excuse me. We just did this like 3 times, guys. What's 1 minus sine squared u? What's 1 minus sine squared u? Cosine squared u.
What identity is that?
Pythagorean identity again. Guys, u, x, theta, it doesn't matter. It's an angle. Sine squared plus cosine squared equals 1. If I subtract cosine or sine from both sides, sine squared from both sides, it leaves me with cosine squared. And what happens to the cosines, guys? I cancel one. So the square gets canceled with this cosine, leaving me with cosine u over 1 minus sine u. Check. Okay. From the problem we just did, 6 should be easier. Please start with one side and get the other side. Try this on your own. Okay, guys, what side do you guys want to start with? Left or right? I think the right, because there's definitely more things to go on here. Now, I did hint at, before I paused it the first time, about multiplying, potentially, in this case, maybe by secant theta plus 1 to the top and bottom. We also, when I did pause it, I did say that, hey, maybe we can set something up with a complex fraction, because what's tangent? Tangent is a sine over cosine. What's secant? 1 over cosine, which creates fractions within fractions, and then I could use the LCD to possibly clean that up as well. So there's options. I'm going to try to show both methods. We're going to start with the method that we started last time, which is the secant theta plus 1, secant theta plus 1. So I'm going to keep these separated on top. So tangent squared times secant theta plus 1. The denominator now I have to FOIL. Secant theta times secant theta is secant squared theta. I'm going to then secant times 1, which is secant theta. Negative 1 times secant is minus secant theta. And negative 1 times 1 is minus 1. The secant thetas will cancel. And that leaves me with tangent squared theta over secant theta plus 1 all over secant squared theta minus 1. Now this one might be a little bit tougher to figure out, but I seem to have a trig function squared and a 1. And anytime I see a combination of a trig function plus or minus 1, I'm going to look at my Pythagorean identities. So, let me write that down again. And I want to get somehow a secant theta. Where does secant theta usually have? Or what is a secant again? A 1 over cosine. So, guys, there were 2 other identities for the trig identities. I said you just memorize this one, you can make those others. And I showed you that if I sit there and divided them all by sine squared or cosine squared, I can make those. I want secant, which means I want it to be the 1 over cosine squared. So that means I'm going to divide everything by cosine squared. Wait a minute, isn't that tangent squared? Plus 1 equals secant squared theta. And then the question is, what is secant squared theta minus 1? It's tangent squared, guys. It's right there. It's right here. If I subtract 1 from both sides, it becomes secant squared theta minus 1, which will equal the tangent squared. So that means this thing right here is equal to tangent squared. And what would happen with the tangent squareds? They cancel. I'm going to take this out of here because I don't need it anymore. I need the room. So that leaves me with secant theta plus 1. But if I look over here, that's not 1 plus cosine theta over cosine theta. So now you have to think a little bit more. What is secant again? Oh, so this is actually becomes 1 over cosine theta plus 1. Which means I can get a common denominator. Cosine theta over cosine theta. And when I put those together, I get 1 plus cosine theta over cosine theta. Check. We just got the other side. We're happy. Now, I'm going to quickly go over the other method. The other method said, hey, looking at that right-hand side, people should recognize that this would be sine squared theta over cosine squared theta. That's tangent squared. 1 over cosine theta minus 1. It creates a complex fraction. What would the LCD of all of that be? Cosine squared. And how do we use the LCD? We multiply to the top and bottoms. And so, wait a minute, cosine squareds cancel, leaving me with sine squared theta over 1 minus cosine squared theta. Because I would have to distribute here. Oops, not 1. Sorry. This becomes a cosine theta. Because the cosine squared and the cosine cancel to be cosine. Can you guys see that I could factor out a cosine of the denominator? I'm trying to think if I want to. No, I do not want to. Yes, I do. That'll work. Oops. So this would be cosine theta of 1 minus cosine theta. Maybe I shouldn't have put it together. Maybe I should have. Maybe I should not have. But what would the top be? Can I change sine squared to something else?
Yeah.
1 minus cosine squared?
Yeah.
No, I can't cancel that. Oh, wait. I'm not going to multiply by 1 plus cosine theta. What is 1 minus cosine squared? It is sine squared, you're right. Or is it the difference of squares? Could the top be 1 plus cosine theta times 1 minus, not sine, cosine theta all over cosine theta times 1 minus cosine theta? Now I can cancel. Leaving me with 1 plus cosine theta over cosine theta, and that's what I wanted. Check. 2 different ways to do the same thing. You guys now have the ability to do the first worksheet. I'm going to check to see about the second one. Yes, we can also do worksheet number 2. So, I want you guys to have for sure worksheet number 1 done, and start into lesson worksheet, the worksheet number 2. Have a great day.